Just as when we were multiplying polynomials, there were some special products that allowed us to use shortcuts. We can use those same shortcuts in reverse to help us factor these special products. And the first special product we're going to take a look at factoring is what's called a difference of squares. You may recall the formula a minus b times a plus b. We had a shortcut to multiply that out. It was the square of the first minus the square of the second. Well, we can use this formula in reverse and take the sum and difference of the square roots. So if I see these two terms subtracted and I can take the square root of both, then it's going to be a minus b times a plus b. Or we add and subtract the square roots. Of course, you all know what a square root looks like in nature. There you go, a tree with a square root. It's kind of more of a rectangular root. Anyways, for example, if I had 9x squared minus 25, I see this only has two terms. It's a binomial, but I do know I can take the square root of both parts. The square root of 9x squared is 3x. The square root of 25 is 5. So I know that I can subtract and add those square roots, and now my polynomial is factored. Here's another one. While I can't take the square roots of both parts here, you do notice that the first thing we should do before we even think about difference of squares is factor out that GCF of 2. That's going to leave us with 4x squared minus y squared. And now I can take the square roots of both parts. The square root of 4x squared is 2x. The square root of y squared is y. Don't lose the GCF out front. So now it's 2x minus y, 2x plus y. Anytime we have a difference of two squares, we can factor it by taking the sum and difference of the square roots. But I want to stress something that's important here. The minus sign in the middle. There must be a minus sign in the middle. I often see students try and factor a sum of squares, something like a squared plus b squared. It does not factor. Does not factor. So if I see something like 64x squared plus 81y squared, yes, we can take the square roots of both parts. It's 8x and 9y. We can take the square roots of both parts, but it still will not factor because we've got that plus in the middle. Remember, if we said it was something squared, there would be a middle term which was twice the product, 72xy and 72xy. And there would be a middle term of 144xy. Because there's a plus in there, we say this polynomial is prime. Just like a prime number has no factors besides 1 in itself, this polynomial has only two factors, 1 in itself. We cannot factor a sum of squares. Now, I alluded to the perfect square shortcut, and you may recall this shortcut that when we've got something squared, we can square the first, and then we multiply them together, and we do that twice, a times b and a times b, so we have two of these ab's. And then we squared the last term. We can use this perfect square shortcut in reverse as well. When we do, we want to make sure we check the middle term, that it's not something that looked like a perfect square, but not actually. So here, it's a trinomial, but I do notice I can take the square root of 25x squared, that's 5x, and the square root of 16y squared, that's 4y. There's a negative in the middle, so it's probably going to be 5x minus 4y, and the whole thing squared. We want to make sure we check the middle term, though, because there are some polynomials that look like perfect squares where the first and last terms we can take the square root of, but the middle term doesn't work. So we'll check the middle term really fast. 5 times negative 4 is negative 20xy. It's there twice, negative 20xy. And negative 20 and negative 20 is negative 40xy. So it does work. Our perfect square answer is correct. How about this one? Hopefully you saw that the first thing we have to do is take out that GCF of 3, leaving behind x squared plus 6x plus 9. And when we do take out the GCF of 3, you notice we can take the square root of the x squared, that's x. Take the sign from the middle, and the square root of 9 is 3, so it's x plus 3 squared. Keep that GCF out front. Again, we always check that middle term. 3x and 3x is 6x, so it does work. We have factored that perfect square using our perfect square shortcut. We also have a formula for cubes. There's two very similar formulas, a cubed plus b cubed and a cubed minus b cubed. They both factor to something very similar. The only difference between them is the signs. And in fact, if I think about the word SOAP for the signs, S-O-A-P, I actually have one formula for both of them. It's going to be a and b in the first factor, the cube roots. The second factor is a squared, an ab in the middle, and a b squared. As for the signs, the S stands for the same sign as the problem. So if the problem had a minus, the same sign is a minus. If the problem had a plus, the same sign is a plus. O stands for opposite. So plus is the opposite of minus, and minus is the opposite of plus. And the last one, AP, is always positive. So same sign, opposite sign, always positive or always plus. Helps you keep those signs in order. So for 8y cubed minus 1, once I see the cubed, I'm thinking, there's a cubes formula. What cubed, what to the third power is 8? Well, 2 to the third power is 8, and y to the third power is y cubed. What cubed is 1? Well, 1 cubed is 1. So the first factor, we take the 2y and the 1 that we just found. The second factor is the bigger one. We square the 2y, so 2 squared is 4y squared. In the middle, we multiply them together. 2y times 1 is 2y. And then at the end, we square the 1. Then for the signs, I think SOAP. Same sign as the problem, so it's a minus problem. Opposite sign of the problem. And the last one is always plus. And what's neat about this is that last factor turns out to be prime. It doesn't factor anymore, so our final answer, 2y minus 1 times 4y squared plus 2y plus 1. Here's another example. 27a cubed plus 64b cubed. Once I see cubes, I think, is something cubed something to the third power 27? Well, 3 to the third power is 27. And a to the third power. So 3a is the cube root. What to the third power is 64? 4 to the third power is 64. And a b. So those are the two parts we're going to use to make our factors. First, we use those two parts, 3a and 4b. Then we square the first one. 3 squared is 9, a squared. Multiply them together. 3 times 4 is 12, ab. Square the last one. 4 squared is 16, b squared. And then I just need to fill in the signs with SOAP. Same sign as the problem is a plus. O, the opposite sign of the problems. And the last one is always positive. And now we have our factored solution. 27a cubed plus 64b cubed is 3ab plus 4b times 9a squared minus 12ab plus 16b squared. So we talked about three formulas, the difference of squares, the perfect squares, and the cubes formula. We can use these formulas to help us solve polynomial equations. Just as before, we want to be equal to 0 first, factor, and set each factor equal to 0. So in this first example, we've got the 25 on the right. We're going to subtract 25 from both sides. So we have 4x squared minus 25 equals 0. We have two terms, and you notice we can take the square roots of each term. The square root of 4x is 2x. The square root of 25 is 5. We need that minus in the middle. We know it's going to be the sum and the difference, 2x plus 5, 2x minus 5, and it still equals 0. Once it's factored, we set each factor equal to 0. 2x plus 5 equals 0, and 2x minus 5 equals 0. And we can solve these two-step equations quickly. Subtract 5, 2x equals negative 5. Divide by 2, and x is equal to negative 5 halves for our first answer. Add 5 to both sides. 2x equals 5. 5. Divide by 2, and for our second answer, x is a positive 5 halves. The second example also does not equal 0. 5x squared plus 10x equals negative 5. So we make it equal to 0 by adding 5 to both sides. Gives us 5x squared plus 10x plus 5 equals 0. Then we can factor it. First thing we do when factoring is a GCF. We can pull a 5 out. That's x squared plus 2x plus 1 equals 0. Noticing I can take the square root of both parts. So it might be a perfect square. The square root of x squared is x. Take the sign from the middle. The square root of 1 is 1. So I think it's 5 times x plus 1 squared equals 0. Check that middle term. 1x and 1x. Yes, that's 2x. So we have factored it perfectly. Now all that's left to do is set each factor equal to 0. X plus 1 equals 0. And technically there's a factor of 5, but we know 5 doesn't equal 0. If there was a variable there, if it was like 5x, then we'd actually get something out of it. But no variable. Really the only good one is this x plus 1. So we subtract 1 from both sides. And there's only one answer this time. X is equal to negative 1. This last example, 27y cubed equals 8. Doesn't equal 0, so we subtract 8 from both sides. Gives us 27y cubed minus 8 equals 0. And when I see that cubed, I'm thinking cubes formula. The cubed root of 27y cubed. What cubed is 27? 3 cubed is. So 3y is the first part. What cubed is 8? 2 cubed is 8. So we've got the small factor and the big factor equal to 0. We use the 3y and the 2. Square the 3y to get 9y squared. Multiply them together to get 6y. Square the 2 to get 4. And then I think about SOAP to put in the signs. Same sign as the problem is minus. Opposite sign is plus. And the last part is always plus. Once it's factored, we can set each factor equal to 0. 3y minus 2 equals 0. And then this factor with the cubes formula, I'll give you a hint. With the cubes formula only, we'll not have any real solutions. And when we get to Algebra 2, we'll take a look at why that is using what's called a quadratic formula. But for now, I'll just tell you, in the cubes formula, the trinomial, the second part, will have no real solutions to it. So only from the first part, the 3y minus 2, we add 2 to both sides. 3y equals 2. divide both sides by 3. And the one real solution is that y equals 2/3. So we looked at a couple special products in this video. We went over them quickly because I want to get you into the homework as fast as possible so you can practice using them. That's the way these really become concrete, is you use these formulas, you start to recognize them, and start to use them quickly. It'll save you a lot of time. That's the difference of squares, the perfect square, and the cubes formula. Good luck on the homework assignment, and let your instructor know if you have any questions.